Every single day, humans eat millions of pounds of chocolate. The global chocolate industry is a beast, pulling in well over $100 billion a year. It's a treat that cuts across cultures, a symbol of luxury, celebration, and plain old comfort. We find it in slick, fancy bars, fun-sized candies, and rich, decadent desserts. But have you ever stopped to think about the incredible industrial power and scientific know-how it takes to feed this global craving? It all starts not in a shiny kitchen, but as a humble bean grown in a narrow strip of tropical land near the equator. In this video, we're taking you deep inside a mega factory to see the wild transformation of that simple cocoa bean into the chocolate bar we all know and love. We're pulling back the curtain on a world of giant machinery, tricky chemistry, and a mind-boggling scale of production. You'll see every key step, from the moment tons of raw beans arrive from all over the world, to the fiery heat of the roasters, through relentless grinding and refining, and into the final high-speed wrapping that preps millions of bars for their trip to your corner store. This is the story of how a bitter seed becomes one of the world's favorite luxuries. Chapter 1. The origin, from tropical pod to fermented bean. Long before any factory roars to life, our story begins in the cocoa belt, the warm, humid regions of the tropics. Here, in countries like Ivory Coast and Ghana, which together produce over 60% of the world's cocoa, grows the Theobroma cacao tree. The name literally means food of the gods, which feels about right. After about 5 years, these trees start producing their famous fruit, large, colorful pods that sprout right from the trunk and main branches. A big plantation might have 500,000 of these trees, harvesting over 1,000 tons of cocoa beans. The harvest happens twice a year, and it's grueling, labor-intensive work done almost entirely by hand. Farmers move through the fields with long-handled knives or sharp machetes, carefully cutting the ripe parts from the trees. They have to be careful not to damage the delicate flower cushions that will grow future fruit. The pods, which can be green, yellow, red, or orange, are gathered into huge piles. Each pod is like a treasure chest holding 30 to 50 cocoa beans, all snuggled in a sweet, sticky white pulp called mucilage. Workers then crack open the thick, leathery husks. With a few practiced whacks of a machete, they split the pods and scoop out the goods. At this point, the beans don't smell anything like chocolate. They're bitter and acidic and still wrapped in that slimy pulp. To unlock the flavor we're after, the beans need to go through a magical process that's part art, part science: fermentation. Right after they're scooped out, the beans and pulp are gathered for this critical step. On smaller farms, they're often piled on banana leaves on the ground and covered with more leaves to trap the heat. In bigger operations, they're loaded into large wooden boxes, which might have small holes to let liquid drain. One of these boxes can hold over a ton of wet beans. The moment the beans are piled together, a complex biochemical party gets started. Natural yeasts in the air feast on the sugars in the pulp, turning them into ethanol. The pulp breaks down and liquefies, draining away as a fluid called sweatings. Then, bacteria take over. First lactic acid bacteria, then acetic acid bacteria, which convert the ethanol into acetic acid and release a ton of heat. The temperature inside the pile can soar to 50 degrees Celsius or 122 degrees Fahrenheit. This heat and acid are crucial. They kill the germ inside the bean so it can't sprout and start breaking down the bean's cell walls. This allows for complex chemical reactions, creating the very first flavor precursors, the building blocks of that chocolatey taste. The bean's color starts to change from a pale purple to a richer brown, and the intense bitterness begins to mellow. This isn't a set-it-and-forget-it deal. To make sure the beans ferment evenly, the whole pile has to be turned or moved to a new box every day or two, a process that can last for 3 to 7 days. Once fermentation is done, the beans are still about 60% water. To be shipped and stored without getting moldy, they need to be dried out, fast. The old-school method is sun-drying. The fermented beans are spread in a thin layer on huge mats or concrete patios. For several days, farmers rake and turn the beans so they dry evenly under the tropical sun. This slow drying is considered the final stage of flavor development. When the moisture content drops to between 6 and 8%, their time in the field is over. The beans, now stable and full of potential, are packed into big 70-kilogram jute sacks, ready for their long trip across the ocean. Chapter 2. Arrival and preparation at the mega factory. That journey from a sun-drenched farm to an industrial complex is a long one. Thousands of sacks of dried cocoa beans arrive at the factory's receiving area, a buzzing hub of activity. These aren't just any beans. They're the lifeblood of the entire production line, and their quality determines everything. Before a single bean gets inside, it has to pass a series of tough quality control checks. As soon as they arrive, lab technicians get to work, taking samples from the sacks and inspecting them. Are the beans healthy, uniform in size, and perfectly fermented and dried? They check for any damage from the trip, like mold or insects. Beans from different places, each with a unique flavor, are carefully identified and catalogued. This lets the manufacturer create specific blends later to get that consistent signature taste. Once a shipment gets the green light, the industrial process kicks off on a massive scale. Powerful vacuum systems suck the raw cocoa beans from their sacks and whisk them into towering silos. These things can be colossal, some standing over 100 feet tall and holding more than 1,000 tons of beans. This whole area is climate-controlled, cool, with good air circulation and low humidity, to protect the beans from absorbing stray odors or moisture. From the silos, the beans move on to their first real spa treatment, cleaning. The trip from the farm can introduce all sorts of junk into the sacks: twigs, stones, sand, even bits of the pod or jute sack fibers. All of it has to go. If not, it won't just ruin the purity of the chocolate. It could destroy the expensive, high-tech machinery down the line. The beans tumble through a series of cleaning machines, starting with vibrating sieves. It's a multi-layered system of screens with different-sized holes. Big stuff like sticks gets caught on top while the beans fall through. Finer bits like sand and dust fall through the smallest holes at the bottom. Next, the beans might pass under powerful magnets to snatch up any stray metal, a nail, a loose bolt, or tiny metal fragments that snuck into the supply chain. Finally, they're hit with powerful vacuums and air currents in a process called aspiration. Jets of air blow away lighter junk like dust and dried pulp, while the heavier, denser cocoa beans carry on. Every last bit of foreign material is meticulously removed, ensuring only pure cocoa beans move on to the next and most fragrant stage. Chapter 3. The heart of the transformation. Roasting. Once cleaned and sorted, the beans are ready for the step that truly awakens the soul of chocolate. Roasting. This isn't just about heating the beans. It's a carefully controlled chemical process that transforms their insides, getting rid of bad flavors and creating the rich, complex aroma we all know. The beans are fed into enormous, rotating steel drums. These industrial roasters are the fiery heart of the chocolate factory, capable of handling thousands of pounds of beans at once. As the drum turns, it tumbles the beans, making sure each one is heated evenly, kind of like a giant coffee roaster. The temperature and roast time are two of the most closely guarded secrets in the chocolate world, precisely controlled by computers and tailored to the bean's origin, moisture content, and the desired flavor. Generally, temperatures climb to between 120 and 160 degrees Celsius, about 250 to 320 degrees Fahrenheit. The roast can last anywhere from 20 minutes to over an hour. During this time, a chemical chain reaction called the Maillard reaction kicks in. It's the same thing that makes baked bread, seared steak, and roasted coffee smell so delicious. It happens between the amino acids and sugars created during fermentation and generates hundreds of new aromatic compounds that give us those nutty, toasty, and quintessentially chocolatey notes. As the beans tumble and heat up, more moisture evaporates and their color deepens to a rich brown. The heat also drives off leftover volatile acids from fermentation, reducing any sourness and smoothing out the flavor. Plus, the high temps act as a final kill step, eliminating any bacteria that might have hitched a ride from the farm. The air in the roasting section of the factory is thick with the intoxicating smell of chocolate. It's a delicate balancing act. Under-roast the beans, and they'll taste sour and weak. Over-roast them, and they'll taste burnt and bitter. The mastery of this one step is what separates mediocre chocolate from great chocolate. Once the roast is done, the beans are quickly cooled to stop the cooking, locking in that perfect flavor before they move on. Chapter 4. Cracking and Winnowing. Separating the treasure. The freshly roasted cocoa beans, now bursting with aroma, are still whole, wrapped in a thin, brittle shell. This papery shell is dry and fibrous and has to be removed. The next two steps, cracking and winnowing, are all about this separation. First, the cooled beans head to a cracking machine. It's designed to be forceful, but not destructive. The beans pass between large, serrated rollers calibrated to crack them into smaller pieces instead of pulverizing them. The goal is to shatter the brittle outer shell and break the inner part of the bean into coarse fragments. What comes out is a mix of two things: small, light pieces of shell and heavier, chunkier pieces of the bean's meat. This inner part is the real prize, known as the cocoa nib. This is where all the flavor and, most importantly, all the cocoa butter is. To separate this mess of shell and nib, the mixture goes to a winnowing machine. Winnowing is an ancient idea, just modernized. The principle is simple. Use air to separate things of different weights. Inside the winnower, the cracked beans are dropped into a chamber with powerful fans. As the mixture tumbles, jets of air blow through it. The light shells are easily caught by the airstream and blown away into a separate chute. The heavier cocoa nibs, however, aren't affected and fall downward through sieves that sort them by size. The process is incredibly efficient, leaving behind a stream of pure, clean cocoa nibs. These nibs are the core ingredient for all chocolate. They're intensely flavorful and contain, on average, about 53% cocoa butter, the natural fat of the bean. Nothing goes to waste either. The separated husks are often collected and repurposed, sold as agricultural mulch or even used in animal feed. For the chocolate maker, blending the nibs is another chance to flex their skills. Here, nibs from different origins and with different roast profiles can be precisely blended. By combining up to 10 different types of nibs, a manufacturer can create a complex flavor and maintain the consistent taste their customers expect, year after year. With the shells gone and the nibs collected, it's finally time to turn this solid stuff into liquid chocolate. We're about to see one of the most magical parts of the process, turning these simple, solid nibs into a flowing river of pure chocolate. If you're finding this journey as fascinating as we do, think about subscribing. That way, you won't miss our next deep dive into the world's most incredible industrial processes. Your support helps us keep going behind the scenes of how our world is made. Chapter 5. Grinding. The birth of chocolate liquor. With a collection of pure, blended cocoa nibs, the prep work is over. Now, the real transformation from solid to liquid begins. The next step is grinding, a process that uses immense pressure and friction to release the rich fat locked inside the nibs. The nibs are fed into a series of powerful mills. In a modern megafactory, this is done with heavy, rotating steel disc mills. The nibs are fed between these grinding surfaces, which pulverize them under incredible force. As the nibs are crushed, something amazing happens. The intense friction generates a lot of heat, enough to melt the cocoa butter that makes up more than half of the nib's weight. As the solid nibs are ground into microscopic particles, the liquid cocoa butter is released and the whole mixture transforms from a dry, crumbly solid into a thick, dark, flowing liquid. This stuff is called chocolate liquor, or sometimes cocoa mass. The name liquor is a bit misleading. It's completely non-alcoholic. It's just the term for cocoa beans in their pure, liquid state. The texture is still a bit gritty as the solid cocoa particles are just suspended in the molten cocoa butter. The flavor is intense, bitter, and complex. The pure essence of the cocoa bean. This chocolate liquor is the crossroads of the factory. From here, its path will split depending on the final product. If the goal is a candy bar, this liquor will be the base. If the goal is cocoa powder, it's off to another machine for a great separation. But in all cases, this thick, aromatic, dark brown liquid is the very heart of chocolate. Chapter 6. The Great Separation, Pressing for Butter and Powder. Not all of the chocolate liquor is destined to become chocolate bars. A huge portion is sent to another part of the factory for a powerful act of separation, where its two main components, cocoa solids and cocoa butter, will be parted. This is how we get two essential products, cocoa powder and pure cocoa butter. The chocolate liquor is pumped into a machine that is the definition of industrial might, the hydraulic press. These are monumental machines capable of exerting unimaginable force, sometimes over 65 tons. The liquor is fed into heavy-duty cylindrical chambers lined with extremely fine screens. Then, a hydraulic ram presses down with immense pressure. Under this force, the liquid fat, the cocoa butter, is squeezed out through the fine mesh screens. It drains away as a clear, fragrant, golden liquid. This extracted cocoa butter is a highly valuable commodity. It has a unique property. It's solid at room temperature, but melts between 31 to 34 degrees Celsius, 89 to 93 degrees Fahrenheit, just below human body temperature. This is what gives high-quality chocolate its signature melt-in-your-mouth feeling. A portion of this butter will be added back into chocolate later to make it smoother. It's also prized by the cosmetics industry for its moisturizing properties. What's left behind in the press is a solid, compressed disc of cocoa solids known as press cake. This cake now contains only about 10 to 20% of its original fat. The cake is then broken up, pulverized, and milled into an extremely fine powder. This is the cocoa powder we use for baking and hot chocolate. Sometimes, the cocoa is treated with an alkaline solution in a process called dutching, which neutralizes some of its natural acidity, resulting in a milder, darker powder. This powerful separation allows a single raw ingredient to yield two distinct products, maximizing the value of every last bean. Chapter 7. Refining, the Quest for Smoothness. Let's get back to the chocolate liquor destined to become a chocolate bar. At this stage, other ingredients are added. Huge mixers blend the liquor with precise amounts of sugar, and for milk chocolate, milk powder. The result is a thick paste. But while it might taste sweet, its texture is far from the luxurious, silky feel we want. It's gritty. That's because the solid particles of cocoa and sugar are still relatively large. The human tongue is incredibly sensitive and can detect particles as small as 30 microns. To get that signature smoothness, those particles have to be ground down even further. This is the job of the refiner. The chocolate paste is fed into a colossal machine known as a roller refiner, typically a series of 3 to 5 massive steel rollers. These rollers rotate in opposite directions at different speeds, creating immense shear force. The paste is fed into the gap at the bottom and pulled upwards, passing through progressively smaller gaps between each set of rollers. The pressure is immense, pulverizing the solid particles against the hard steel. The paste is smeared into an increasingly thin film, with the particles ground down to a microscopic size. By the time it's scraped off the final roller, the particle size has been reduced to an astonishing 20 to 30 microns, well below what the human tongue can perceive as grainy. This refining process is essential for creating that smooth, velvety mouthfeel. It ensures that when a piece of chocolate melts in your mouth, it feels completely seamless. The result is a warm, thick, and now incredibly smooth chocolate paste. But while the texture is almost perfect, the flavor isn't quite there yet. The chocolate still has some harsh notes. The final and perhaps most time-consuming stage of flavor development is still to come. Chapter 8. Conching, the art of flavor and texture. Development. The smooth, refined paste has the right particle size, but it lacks the final polish in taste and texture. The next stage, conching, is the longest and one of the most critical processes in the factory. It's a slow, patient refinement that turns the paste into a truly luxurious indulgence. The process gets its name from the shell-like shape of the original machines, which were invented by Rodolphe Lindt back in 1879. The paste is transferred into enormous machines called conches. These are basically giant, heated vats with heavy, slow-moving rollers that continuously plow through the chocolate mass. A modern conch can hold up to 9 tons of chocolate. For anywhere from a few hours to several days, the chocolate is constantly agitated and heated. Some premium chocolates can be conked for up to 72 hours or more. Conching does several crucial things at once. First, it develops the flavor. The constant motion and gentle heat, set between 50 and 90 degrees Celsius, 192–194 degrees, cause volatile acids and moisture to evaporate. Any lingering sour notes are driven off, making the flavor rounder and less bitter. The heat also promotes more gentle Maillard reactions, deepening the roasted, nutty flavors. Second, it perfects the texture. The continuous motion rounds off the microscopic edges of the sugar and cocoa particles. At the same time, the process coats every single solid particle with a thin film of cocoa butter. This is what gives the final chocolate its viscosity, or flow, and its silky, melt-in-your-mouth quality. Late in the conching process, the final ingredients are added. This is when extra cocoa butter is mixed in to get the right fluidity, along with an emulsifier like lecithin, which helps stabilize the mixture. Flavorings like vanilla may also be added here. Conching is where the chocolate maker's art truly shines. The duration, temperature, and speed are all variables that create distinct flavor profiles. When it's done, the chocolate is no longer just a paste. It's a homogeneous, velvety, aromatic liquid, its flavor fully developed and its texture perfectly smooth. Chapter 9. Tempering, the secret to the snap and shine. The beautifully conched chocolate is now smooth and flavorful, but one final, crucial scientific step remains: tempering. If you've ever melted and resolidified chocolate at home, you know it often ends up dull, soft, and crumbly. That's because it wasn't tempered. Tempering is a precise process of heating and cooling that gives chocolate its attractive glossy sheen, its satisfying snap, and its ability to stay solid at room temperature. The science behind it is all about controlling the crystal structure of the cocoa butter. Cocoa butter is a complex fat that can solidify into 6 different types of crystals, known as forms 1 through VI. Forms I through IV are unstable, soft, dull, and with a low melting point. The holy grail is Form Phi. This is the stable crystal that gives chocolate all its best qualities: a beautiful gloss, a firm snap, and a melting point just below body temperature, so it melts perfectly in your mouth. The goal of tempering is to encourage as many Form V crystals as possible to form. In the factory, this is done in sophisticated tempering machines through a carefully controlled three-stage cycle. First, the liquid chocolate is heated to about 45 to 50 degrees in 113–122 Celsius to melt all existing fat crystals, creating a clean slate. Second, it's slowly cooled to around 27–81 degrees. This encourages the formation of the initial seed crystals, a mix of the unstable Form Phi and the desired stable Form Phi. Third, the chocolate is gently reheated just a few degrees to about 30 Fahrenheit for dark chocolate, around 88–91. This is just enough to melt away the unstable Form Phi crystals, while leaving the stable Form V crystals intact. What's left is a liquid chocolate filled with stable Form V seed crystals. It's now in temper. When it cools, the remaining liquid, cocoa butter, will crystallize around these stable seeds, resulting in a finished product that's uniformly strong and shiny. This complex operation is monitored electronically to ensure absolute precision. The perfectly tempered chocolate is now finally ready to take its final shape. Chapter 10. Molding and Cooling. Taking final form. With tempering complete, the liquid chocolate is in its perfect state, fluid, glossy, and ready to become a bar. It's quickly moved to the molding line, a marvel of automation. The tempered chocolate is pumped into the hoppers of depositing machines, which are positioned over conveyors carrying thousands of empty molds. With pneumatic precision, nozzles squirt the exact amount of chocolate needed to fill each cavity. If the bar has fillings like whole nuts, they're often placed in the molds first. For soft fillings like caramel, a process called shell molding is used. A thin layer of chocolate creates an outer shell, which is then filled before being capped with more chocolate. Immediately after being filled, the molds pass onto a vibrating table. This shakes out any tiny air bubbles, ensuring the final bar is solid and dense. From there, the molds begin their journey into long, cooling tunnels, kept at a steady, cool temperature of around 17 degrees. Controlled cooling is essential. As the chocolate cools, the stable Form V crystals act as a template, and the entire mass solidifies. A neat trick of physics helps here. As tempered chocolate solidifies, it shrinks just a tiny bit. This is enough to cause the hardened bar to pull away from the sides of the mold. After emerging from the cooling tunnel, the molds are flipped over and, with a gentle tap, the solid, glossy, and perfect chocolate bars fall out. Chapter 11. Packaging, the high-speed finale. The freshly demolded chocolate bars, now glossy and firm, are a testament to their long journey, but they aren't ready for the world just yet. The final stage is packaging, a high-speed, fully automated process designed to protect the product on a massive scale. The bars travel along conveyor belts to the wrapping lines in a dazzling display of robotics. High-speed cameras may scan each bar, checking for any imperfections. Any bar that doesn't meet the strict specs is automatically rejected. The perfect bars continue to the wrapping machines. In a blur of motion, robotic arms perform a perfectly choreographed dance. First, a bar might be wrapped in foil to protect it from light and moisture. Immediately after, the same machine wraps the foil-covered bar in its outer label. The process is so fast it's hard to follow, with machines wrapping hundreds of bars per minute. Once wrapped, the bars are arranged, stacked, and placed into display boxes. These boxes are sealed, coded with tracking info, and loaded into larger shipping cartons. The cartons are then robotically stacked onto pallets, shrink-wrapped, and transported to the factory's warehouse. From here, they'll be shipped to distribution centers and then to stores around the globe. In just a few hours, millions of identical chocolate bars are produced, wrapped, and dispatched. From a bitter bean fermented under the tropical sun, a remarkable transformation has occurred. We've seen it endure the fiery trial of the roasters, where its true aroma was born. We watched as it was ground by immense force into a dark liquor, refined to microscopic smoothness, and patiently conked for days to perfect its flavor. We delved into the precise science of tempering, the intricate dance of heating and cooling required to give the final bar its signature gloss and snap. Finally, we saw it molded, cooled, and sent through a lightning-fast packaging line. The journey from bean to bar is a symphony of agriculture, chemistry, and engineering. It combines ancient traditions with cutting-edge technology, all orchestrated on a scale that's hard to wrap your head around. So, the next time you unwrap a chocolate bar, take a second. The smooth texture, the glossy shine, the clean snap, and the rich flavor aren't accidents. They are the result of a meticulously controlled, scientifically perfected process that turns a simple seed from the food of the gods into the world's favorite treat. What did you find most surprising about this industrial journey? Let us know in the comments below. If you enjoyed this look behind the scenes, give this video a like and be sure to subscribe so you don't miss our next exploration into the fascinating world of manufacturing. Thanks for watching.